So let me introduce myself. I am Mattia Lavacca. I am a former student here at Politecnico di Torino, and I work as a software engineer at Kong, a company which provides cloud connectivity. And this talk is about the Gateway API, which is the next generation of the Ingress API. Well, let's start with the agenda. The first thing we will talk about is the Ingress API overview. So what the Ingress API is needed for, and what are the features, what are the limitations, and so on and so forth. And which is the reason behind the need of introducing a new, let's say, a new API, which aims at being... Oh, sorry, I wasn't sharing my screen on Zoom. Is it fine? Okay. So, what are the features of the Ingress API? What is the need of introducing a new API of, of this kind? So we will get to the Gateway API. We'll provide an overview of such an API, and we will introduce the model behind that API. So we will see very briefly all the main resources that we will use during the demo, such as the GatewayClass, the gateway, routes, and reference guns, and then we will spend some time on demoing something. So we will show something and how to deploy a gateway, how to expose application, and all this kind of stuff. As a first introduction, I would like to, to state a bit about the API lifecycle in Kubernetes. There are three main different stages that an API will, will have during the graduation phase. Every API starts from the alpha, then graduates to beta, and then graduates to GA, which is generally available status. Kubernetes has many core APIs, many standard APIs, such as deployments, services, nodes, and so on and so forth. And these APIs are already installed, already exist in every Kubernetes cluster, every vanilla Kubernetes cluster that you create, that you install, and that you manage. So these are standard APIs. Then there are the extended API, there are the additional APIs, but that are supported by the Kubernetes community, such as, for example, the Gateway API. The Ingress API belongs to the first group of these APIs. So in every single Kubernetes cluster, you will find the Ingress API. So you will be able to create an Ingress class, you will deploy an Ingress controller, and everything will work out of the box. While for what concerns the Gateway API, this is not included in the this is not included in all the Kubernetes distributions. So you have to deploy the CRDs, you have to manage the API lifecycle, because the cluster will not deal with these kind of issues on behalf of you. So we said that we have three different stages: alpha, beta, and GA. Ingress API is a GA API, so it's generally available. It's a quite old API. It is very widely used. There are a lot of implementations for the Ingress API. And for what concerns instead the Gateway API, it is a fairly new API. So we have a bunch of APIs that have already graduated to beta, while others are still in alpha. What alpha, beta, and GA means? Well, alpha means that the API is not yet stable. You have to use it and deploy it with carefulness. Okay, so we generally these kind of APIs are not yet ready for production, may be buggy, may lack some features, or may have the support dropped in the near future. You don't know. You don't have any guarantee on the API which are in alpha stage. While for what concerns the beta APIs, well, beta APIs should be more stable. They can be used in production environments, even if you should do it with care, and they are enabled by default. By default, what does it mean by default? Alpha and beta features are exposed generally through feature gates. So to enable this kind of feature in an implementation that, for example, controls that kind of APIs, you should provide a feature gate. The feature gates is nothing more than a flag given as an argument or as environmental variables. So you just need to provide such a feature gate. For API in alpha, that feature gate is defaulted to false. So you have to enable them manually. For beta APIs, the feature gate is enabled by default. So you can switch them off. You can remove the support to that kind of APIs, but they are enabled by default. While for GA APIs, so they are graduated, they should be very stable. They should be ready for production. And so there is no feature gate behind them. You have to use it. You have to deal with that. So we say that the Ingress API is GA, is widely used, and what it is needed for? It is needed for basically exposing services outside the cluster boundaries. You know that we have three different types of services, which are cluster APs, node port, and load balancers. Node port and load balancers can be reachable from outside the clusters, while cluster APs cannot. So basically, you can use the Ingress to expose many different services. So you can use just one Ingress to expose many different deployments that are exposed through services using cluster AP. So you don't have to create a load balancer for each single service. You don't have to use many different public IPs. And also you can provide additional features on top of routing, such as load balancing or path matching and all this kind of stuff. It's a GA API, as I said before. And of course, even if the Ingress is a standard API, you need an Ingress controller to use it. The Ingress controller is not included in the Kubernetes Ingress controller, such as, for example, the deployment. To use a deployment in Kubernetes, you don't have to deploy an additional component to reconcile that deployment to create the pods out of that. But for Ingress API, you need a controller because the Ingress controller is an implementation, and you may need some features instead of some others. For example, the most famous one, well, the most used one at the moment is the Nginx Ingress Controller. Features, the Ingress API has a limited set of features. So we have the forwarding to services, the host and path matching, and you have the possibility to configure TLS. But it has a lot of limitations. The limitation is that these features are not enough. We might have the need to have additional features, additional capabilities on top of the API. There are a lot of custom extensions, and this comes from the lack of features of the Ingress. So all the implementations, such as the Ingress controller, the Nginx Ingress controller, exposes a set of annotations to expand, customize, and improve the capabilities of the Ingress API through annotations. And this is not a very good approach, because you will end up having tons of different annotations, and each annotation is specific for each implementation of the API. So there is not a standard approach on that. And the last one, the last limitation, is that there is no a permission. There is not a good permission model, because the community didn't consider that back in time when the API was created. So there are the main components, which are the Ingress class, and that's it basically. So the Ingress will have a set of rules. Each rule wire a service so that you can access a service from outside the cluster by using the Ingress API. So for this lack of features, the Gateway API, the Gateway API comes to overcome this kind of problem. So this is the next generation of the Kubernetes routing and load balancing API. And it's in beta from July 2022. As I said before, only a subset of APIs are in beta at the moment. Only the gateway, HTTPRoute, and GatewayClass. All the other APIs are still in alpha, and some other will be graduated to beta in most likely in a few days or a few weeks. As for the Ingress controller, Ingress API, sorry, the Gateway API needs a Gateway API implementation, so it needs a Gateway API controller. An example of that is the Kong Kubernetes Ingress Controller. I know that the name can be misleading because the Kubernetes Ingress Controller reconciles the Gateway API, but the reason is that the Kubernetes Ingress Controller from Kong reconciles both the Ingress API and the Gateway API. And so the name is kind of a legacy that we have because back in time there was no Gateway API. And move on to the features. The features are quite rich and are going forward. I mean, the feature set is going to be improved in the near future. So we have the possibility to create to attach TLS configuration. We can perform HTTP matching, not only path and hostname matching, but we can perform path, hostname matching, header matching, and query matching. It means that we can perform routing based on, for example, some headers in the HTTP packets. Then we have the cross namespace resource binding and cross namespace forwarding. What does it mean? It means that you can have some components of the Gateway API in, let's say, a namespace A, and those components can refer to a service in namespace B in a native way, but enforcing some restriction policies to not allow that by default. But you have to do some operation that we will see afterward. Then we have the HTTP filters, the possibility to attach HTTP filters, which means that we have the possibility to, for example, create, update, delete headers to the HTTP packets. So, for example, if HTTP response comes, the data plane can add an header or can remove an header from that packet, and the same for the response. And there are some other filters which provide this kind of interactions with the HTTP packets in different ways. And the last one, well, not the last one, but one very important feature is the weight-based traffic splitting. So we can set a weight to each different route to perform weight-based load balancing, weight-based traffic splitting in a native way. And when I say native, I mean that we don't need to use annotations or custom extensions. It is everything embedded in the API. If an implementation is conformant with the API, then that implementation will have all these features. So we have these resources. These are the main resources. This is the schema, let's say. And we have the gateway, the GatewayClass, HTTPRoute that connect the gateway to the service. If we go back and take a look at the Ingress, we can see that we have an additional layer of resources. before we had only Ingress and Ingress class, while here we have gateway, HTTPRoute, and service. Well, basically, the Ingress is more or less the same of the HTTPRoute. So the HTTPRoute can be seen as the successor of the Ingress, because in the HTTPRoute you specify rules, you specify traffic splitting rules, weights, backend references to to bind the services to the gateway, and all this kind of functionalities. So what does the gateway is needed for? The gateway is needed to provide an abstraction to the data plane, basically. So through the gateway, you can access the cluster. So it is kind of a access point to the cluster, and in the gateway you will have the listeners. So all the ports that are bound to the external EP that will be exposed through the gateway. And well, it can be basically seen as an access point for the cluster. And the HTTPRoute is the object that aims at connecting the gateway, so the access point of the cluster, to the internal service. So let's talk about another thing about the Ingress, the gateway class. What is the gateway class? The gateway class is an object that is referenced by the gateway and is used to specify all the gateways that must be reconciled by a specific implementation. So if a gateway aims to be reconciled by the Kong Ingress Controller gateway, then the gateway class that is used by the gateway should be specifying a field in the spec that says, okay, I want to be reconciled by the Kong Kubernetes Ingress Controller. And the same was for the Ingress class. What is the model of the Gateway API? Well, we have, as I just said, the gateway class, the gateway, the HTTPRoute, and the services. The gateway class can be managed, well, should be managed by the infrastructure provider. So this is kind of a separation of concerns between all the personas that operate on the cluster. The gateway class should be managed by the infrastructure provider, while the gateway should be managed by the cluster operator. So the cluster operator should not have access to the gateway class, because the gateway class is very bound to the gateway class, to the gateway controller, to the implementation that we use to reconcile this kind of API. Then we have the gateway, which is managed by the cluster operator, and the HTTP routes, which are managed by the developers, because developers should be able to, to create the microservice schema of the application and to connect them and to expose them. And you can achieve so by dealing with HTTP routes, because HTTP routes specify rules and all the kind of features that I mentioned before. So let's take a look at the resources. The first one, as I said, is the gateway class. This is a very tiny resource. It only specifies the controller name in the spec, which is the field that I was talking before about. And this field states, okay, I am a gateway class, and all the gateways that reference me as a gateway class should be reconciled by the controller, which is called konghq.com/gateway operator. There is an additional field, which is the parameters ref. Parameters ref is a reference to an object, to an API in Kubernetes that aims at providing additional configuration to the control plane and the data plane. But we will take a look at that after during the demo. Then we have the gateway. Gateway, as I said, specifies the gateway class through the gateway class name field, and it specifies a list of listeners. A listener, as I said before, is kind of an access point to the cluster. For example, here we have this listener that exposes port 80 and uses protocol HTTP. Then we have the HTTPRoute. HTTPRoute is the resource that specifies all the rules, all the routing rules, and it uses Kong, which is the name of this gateway, as parent ref, and it specifies a set of rules. The first rule, for example, well, here we have only one rule, so it specifies that it should match all the paths that have login as prefix, and all that these hits should be forwarded to the auth service, which is specified in the backend refs. So to wrap up this part, we have this gateway with a listener on port 80, and we have this HTTPRoute that has this rule with /login with path prefix. It means that every time the external IP of the gateway is hit to the port 80 and the path /login star, so it's a prefix, so everything which has prefix as /login, it will be routed to the service that is called auth service, to port 80. And the last API, which is not still in beta, it is still, which is not yet in beta, sorry, it is still in alpha, as you can see here, is the reference grant. And the reference grant is needed for allowing cross namespace reference and cross namespace traffic forward. So you can see, for example, here that this reference grant lives in the namespace named namespace 2, and it allows the reference to the service called auth-svc from all the routes, all the HTTP routes that live in the namespace 1. So if you have this HTTP route that is created in the namespace 1, but it references to a service in the namespace 2, you will need this kind of reference grant. Otherwise, the reference should not be working. And now we have a demo of this concept. So let me clean up a bit here. Okay, this is a kind cluster. We have all the main components of the, see? Yes, sure. Is it better? A bit more? Let me do the same for the others. Okay. So it's okay. We have this kind cluster with all the standard components that you can find in any Kubernetes cluster, with the addition of MetalLB that is needed for assigning public IPs on my local machine. So basically, I can create load balancer services, and those services will have the addresses provisioned by MetalLB. Okay, so let's start by deploy. As I said before, as I said during the introduction, the Gateway API is not a standard API. So it is not included in this cluster, because this cluster is a vanilla Kubernetes cluster. It doesn't have a Gateway API. Indeed, you can ask to kubectl to explain what an ingress is, and it will reply, okay, this is an ingress. But if you do it the same for the gateway, it will most likely say that the server doesn't have a resource type gateway because the CRD of the gateway is not installed yet in my cluster. So as a first step, we should install such a CRD, right? So I have a script that, okay, let's move here. I guess I should zoom a bit. You can read it? More or less? Better? Okay. So we have this very, very simple script, which basically installs the Gateway API, the beta, the beta resources that belongs to the Gateway API. So which is this line. This line installs the experimental Gateway API, and we need it for the reference grant, which I say that it is still in alpha. So we need it. Then we have to install a set of CRDs that are needed by the control plane, but they are not important for our purpose, but I have to install them because otherwise the demo will not work. And the last one is the gateway operator. The gateway operator is the operator that will reconcile our gateways and will provision the control plane and the data plane upon the gateway creation. So let's deploy all these resources. My internet connection is not great, so I hope that everything will be smooth. Okay, well, in the meantime, I can just try to see something. Okay, let's get the gateway class, the gateway, control plane, data plane, that you don't know what they are, but you will find out very soon, deployment and services in, sorry, this was for later. Now we should see that we have this gateway operator controller manager, which has been created in the namespace Kong system, which is the gateway controller, and a bunch of additional resources that are not meaningful for us at the moment. So let's wait until they will be created. The gateway operator admission, create, and patch are simply pods that are created out of jobs that are needed to create certificates for the validating webhook. I guess that you know what a validating webhook is. It's kind of a backend that is contacted by the API server every time a resource of a certain type is created, updated, deleted, and so on and so forth. So every time we create a gateway, the API server contacts our validating webhook, and the validating webhook validates that the gateway is a well-formed resource, basically. And it can be accepted by our implementation because we wrote this admission webhook. So we have the controller which is running and everything looks fine. So at this point, we can create some backend, some workload, because we want to expose the final goal of our demo is to expose some workload to outside the cluster boundaries. So we will create a couple of deployments. All the deployments are the same image, basically. They are a simple echo server that when it's contacted replies with the current time. So we create two deployments, Alice, called Alice and Bob, and Alice and Bob are exposed by two different services, service Alice and service Bob. So let's deploy all these resources. Okay. And we can take a look at them. So we have these two deployments, which are Alice and Bob, two pods that have been created out of them by the Kubernetes controller manager, and two different services, Service Alice and Service Bob. Those services are cluster IP, so they are not natively reachable from outside the cluster boundaries, because they are only routable inside the cluster network. So we just want to check that everything is working as expected. So first of all, we should wait that the pods get in running status. Then we can try to port forward those pods to check that they reply as we are expected to see. And so we will get the same reply when we will expose them to outside the cluster. Sorry, as I said, the internet connection is kind of an issue at the moment. Okay, should be ready. Yes, they are ready. So let's try to expose them. Let's try to port forward them and contact them by from our localhost. Okay, so port forward, as we see Bob, and I will bind the port 80 of the container to the port 8080 of my machine, of my localhost. So the port is being forwarded, and I can curl localhost on port 8080, and I can see that the service replies with the current time. So Bob is working. We can guess that Alice is working as well. And now let's try to expose these two deployments to the outside the cluster boundaries. So we need what we need. We need a gateway class, and an HTTPRoute, as I said before. Let's take a look at them. Well, the first one is another component that we will take a look very soon. The first one is this gateway class, which specify the controller name, as I said before, and the gateway that uses the above gateway class name and exposes the port 80. So it uses a listener that uses protocol HTTP with port 80. The last resource is this one, which is the gateway configuration, which is a proprietary CRD from Kong. Well, not proprietary, is not owned by the Kubernetes community. It is owned and maintained by Kong, because it is a component that is needed for customizing the control plane and the data plane with various features that we may need. For example, as I said before, the gateway, all the features that are still in alpha need a feature gate to be enabled, and we need it because we want to use the reference grant. So we have to specify that the feature gates for the controller should include the gateway alpha feature gates. So we want to use the alpha API of the gateway API. Then let's deploy them. Okay. Let me resize this terminal. So we can see that we have this gateway class. We have this gateway, which is called Kong, and we have two additional resources, which are the control plane and the data plane. these resources have been just created by the gateway operator, because the gateway operator is a Kubernetes controller that reconciles the gateway API resources and creates other resources to manage them. And basically, it keeps the original resource status updated with the current status that we have in our cluster. Talking about this specific context, we have that the gateway operator reconciled the gateway that we just created and created two different objects, which are the control plane and the data plane. Control plane and data plane are backed by two backends, which are the control plane backend and the data plane backend. The control plane is the Kubernetes Ingress Controller, which is a controller that aims at reconciling the HTTP route that we will create, while the data plane is Kong, which is indeed a data plane, which is the place where all the traffic, all the cluster traffic pass through and is routed. So all the traffic that comes from the gateway and is directed to other services internal to the cluster is forwarded by the data plane. And the data plane, as I said, is Kong. So we have this control plane, we have this data plane, we have these two different deployments that bake these two resources, and the gateway has a public IP address, because if I curl 172.18.3.1, it will reply with the standard message from the Kong data plane, that is, there is no routing to perform because you are just contacting the gateway and there is no rule, there is no route that can be, there is no routing that can be performed. So what we need now, we have the gateway, we have the backend, and we have to connect the gateway, the access point to our cluster, to the backends through an HTTP route. So we can take a look at the HTTP route, which is this one, and it will specify Kong as a gateway and a set of rules. Let's take a look at the first two rules. The first one says that all the client that tries to connect to /echo, to the path /echo, exactly, not as a path prefix, but exactly to /echo, and having the headers person : Bob, will be redirected to the service named Bob to port 80. The same exact thing for Alice, except for the headers. So basically, what we want to say is that I want to curl the same exact IP address, which is that 172 blah blah blah, to /echo, and by providing two different headers, my request will be routed to two different backends, which are Bob and Alice. So let's do that. Let's create the HTTP route. Okay. And I can then curl, sorry, let's look at the external IP, which is 172.18.3.1, is one, with header person dot Bob. Sorry? Ah, you're right. Yes, no. Okay, so with the correct header and with the correct path, we are just we have just contacted Bob as a backend. So if we log Bob, we can see that we are actually talking with him. So let's log Bob and Alice. So let's contact again Bob, and we see that Bob is logging something. So it is actually Bob that is talking with us. And if we try to talk with Alice, we can say that, okay, I'm talking with Alice. So the routing is performed in the way that we expect. So we can now just perform another layer of routing, which is, okay, let's deploy another component, which is Jack. The same deployment, the same component, but in another namespace. So we have this demo2 that deploys another namespace named demo2, and the same deployment, two different deployments actually, Jack1 and Jack2, exposed by service Jack1 and service Jack2. All of them in the demo2 namespace. So, okay. Then we can see that Jack is running, while the two instances of Jack are running, Jack1 and Jack2, and they are exposed. And if we look at the HTTPRoute that we created before, there was already the rule about Jack, because we see that Jack is reachable by using the header person:Jack, and there are two different backends, Jack1 and Jack2. The first one has weight 2, and the second one has weight 1. So we expect that we will hit Jack1 2/3 times of our request, and Jack2 1/3 times. So the deployments are there. The HTTP route is configured as expected, and we should be able to talk with Jack, right? So person, not Alice anymore, but Jack anymore, but it doesn't work. Why it doesn't work? It doesn't work because, as I said at the beginning, there is this kind of isolation implemented natively in the API. So the HTTP route that is created in the Nemo namespace should not be able to reference to a service that is created in another namespace, because we want to keep the namespace isolation, and we want to keep the possibility to have kind of a walls between namespace and not allow the HTTP routes and the services and the gateways to be bound one to another across different namespaces. We don't want to have this behavior by default, but we want to allow it when we need it. And to do so, we have the resources that I mentioned before, which is the reference grant. The reference grant is this resource, and we are saying that the HTTP route that lives in demo namespace can be bound to all the services, well, not all, but to Jack1 and Jack2 services that are created in the namespace demo2. So let's try to create this reference grant. So now we should be able to talk with Jack, right? And we are. So if we log what Jack says, as we did for Bob and Alice before. Okay. Okay. We can see that we are talking with them, but we should be able to see that we will reach them with different weights, because we specified different weights on the route. So we can see that here we just hit Jack 2, here Jack 1, here Jack 2, Jack 1, Jack 1, Jack 1, Jack 1, and so on and so forth. It is important to notice that 2 times over 3 we should hit Jack 1. 1 time over 3 we should hit Jack 2. But it is not. It can happen that there is no that specific pattern 2 1 2 1 2 1. But when we have a sufficient amount of requests, we can see that that pattern is respected. So we will have overall 2 over 3 times Jack 1 contacted and 1 over 3 times Jack 2 contacted. And so this is the reason why we need the reference grant and how to allow cross namespace references. It is worth to notice that such a resource can be used also to enable cross namespace reference, not only from HTTPRoute to service store, not only cross namespace forwarding, but also cross namespace binding from HTTPRoute and gateway. So for example, if you have a gateway in namespace A and you want to use that gateway from an HTTPRoute in namespace B, you will need a reference grant as well to allow that cross namespace reference. And I guess that's a wrap for our demo.